Hello, hello, hello. Math 112. So we are moving on to section 3.3, and then we'll also talk about section 3.4 this week. But long division and synthetic division, if you took Algebra 2, you did both of these things, I hope. And that's something called the remainder theorem and the factor theorem. So first of all, long division. Well, this is how you would divide integers by long division. So you take 203 is being divided by 13. 13 is the divisor, and your answer is going to be the quotient. So the process is you take your divisor, 13, and you try your hardest to eliminate the dividend piece by piece. So 13 um, is this two-digit number. So you look at the first two digits, 20, and 13 can go into 20. If it couldn't, if this were like 127 or something, I would have to look at the entire three-digit number. But 13, maybe it's best to think of it this way. 13 can't go into 2, so then you increase it. 13 can go into 20, and it goes into 20 exactly one time. So you put a 1 there, and then you multiply 1 times 13, and you get 13. And then the next thing you do is subtract. 20 minus 13 is 7. So that's the process, and then you repeat that step. But to begin again, you have to drop down that next digit. 3 would drop down right here and make it 73. And here you start again. How many times does 13 go into 73? And I believe it goes in there 5 times. 5 times 13 is 65, and then you subtract. 73 minus 65 is 8. Now 8 is too small for 13 to go into, so that's how we know we are done. And we are done with the algorithm. We have divided 203 by 13, but what is the answer? Well, that means that 203 divided by 13 equals 15 and 8/13. So 8 is the remainder, and you always take the remainder divided by the divisor to finish off your fraction. 15 and 8/13 is the correct answer, but that is the same thing mathematically as 15 plus 8/13. So what I can say is 203 divided by 13 equals 15 plus 8/13. If I multiply both sides by 13, then this becomes 203 equals 15 times 13 plus 8. A lot of times it's written in this form too. So you have the dividend, the quotient, the divisor, and then the remainder. And 203 divided by 7, same process. You figure out how many times does 7 go into 20. 2 times. 2 times 7 is 14. You subtract, get 6, drop down to 3, and then again. So how many times does 7 go into 63? 9 times. So 9 times 7 is 63. Subtract, you get 0. And this here, the remainder is 0. That's very, very important for us, because if the remainder is 0, then 7 divided 203 evenly. And which means 7 is a factor of 203. And also, the result was 29, the quotient. That also means that 29 itself is a factor of 203. And you could write it like this: 203 is 29 times 7. So 29 and 7 are both factors of this. So that only happens when the remainder is 0. We can apply the same idea to, polynomials. So here I want to divide f by g, and f is this cubic polynomial, g is a line. So the divisor always goes out here, and you want to, let's see here. You're going to put something up here. It's the same idea with those numbers. 3x plus 2 goes into, how many times does it go into this? And the key thing that you are always allowed to do is you can always find an answer that will eliminate that first term. That is the key thing. You want to put a number up here so that when you multiply this, you get 3x cubed. So x squared is going to be the first answer in our quotient, the first part of our quotient. So now I would take x squared times 3x and x squared times 2. All I'm really doing is taking x squared times the divisor. But since the divisor is two terms, I have to distribute. So x squared times 3x, x squared times 2, and the result is just 3x cubed plus 2x squared. And then you subtract. You will always have like terms lining up. So these two things cancel, which is the key component. Remember, this was supposed to cancel. And after you subtract, this does cancel. But 5x squared minus 2x squared leaves you with 3x squared. And then you drop down the 8x, and then you start the whole process over again. You find out how many times does 3x plus 2 go into here. Well, just focus on that first term. Just eliminate 3x squared. So what could you put up here that when you multiply this, you're going to get 3x squared? And the answer is x, positive x, plus 1x. So that plus 1x is going to be multiplied by 3x and then again by 2. And when that happens, x times 3x is 3x squared. X times 2 is 2x. So you get this binomial. And you subtract again. So when I subtract these two, well, the 3x squareds cancel out. 8 minus 2 is 6x, and you drop down the 7. And then now again, how many times does 3x plus 2 go into 6x plus 7? Well, don't worry about the plus 7, just eliminate the 6x. So what could you put up here so that when you multiply this, you get 6x? And the answer is 2. 2 times 3x is 6x. 2 times 2 is 4. So you subtract again, the 6x's cancel out, leaving you with 3. 3 is the remainder. 3 is too small for 3x plus 2 to go into, so 3 is the remainder. So our final answer is x squared plus x plus 2 with a remainder of 3. So to write the remainder of 3, we did it just like we did with the numbers. We take the divisor, which is 3, the remainder, which is 3, divided by the divisor. Before it was like 8 over 13. Well, now it's 3 over 3x plus 2. So when I take f of x divided by g of x, I get this quotient plus the remainder divided by the divisor. And it's definitely worth noting that since we have a remainder that's not 0, so in other words, it's 3, it did not divide evenly. So 3x plus 2 is not a factor of 3x cubed plus 5x squared plus 8x plus 7. Another example, f divided by g. This one is different in a meaningful way. F is 2x to the fourth. That's the dividend. And it's 2x to the fourth minus x to the third minus 2. You may have noticed that we skipped over x squared and we skipped over x to the first. Well, we need placeholders there to account for this division. So 0x squared is needed as a placeholder and 0x. Of course, 0x squared and 0x are just 0. They're nothing, but they're needed as placeholders, and we'll see why. So what do I put up here so that when I multiply all three of these, I get a 2x to the fourth right here? And the answer is x squared. You can really put the x squared anywhere. I like to keep all the degrees in order. So x squared times 2x squared times x times 1. So you're really distributing, and you put all those answers right there. Well, x squared times 2x squared is 2x to the fourth, times x is x to the third, times 1 is 1x. And then you subtract. These two cancel out. Here, be very careful. I want you to answer in your head, what does this equal after you subtract? Negative 1 minus 1 is negative 2. So negative 1 minus 1 is negative 2. Be careful with the subtraction. It can be slippery. And 0 minus 1 is negative 1. And then you drop down that term. And then you start the whole process over again. What could you put up here so that when you multiply this, you're gonna get a trinomial. because you're taking one term times 3 terms. So you're going to get a trinomial, but you want this first term to be negative 2x cubed, so it cancels out. And the answer is negative 1x. So you multiplied these 3, and we get this new trinomial. We subtract. These 2 cancel out. And here, this one's even more challenging. Negative 1 minus negative 1. Well, you're subtracting 2 things that are the same, so they completely cancel out. What about 0 minus negative 1? That's positive 1. So positive 1x, drop down the minus 2. And you would continue again, but your divisor is a second degree, and what you have left over is a first degree. How can a second degree fit into a first degree? You would have to have x to the negative first up here, and that would suddenly not be a polynomial anymore. So this is, you're done. This is your remainder. So the answer to f divided by g is the quotient plus the remainder divided by the divisor. So this right here. Here's the quotient plus the remainder divided by the divisor. And again, since we had a remainder that wasn't 0, I know that I don't have a factor. I did not divide by a factor. There is another way to divide called synthetic division, and it is much more efficient than long division. But synthetic division can only work when you have a linear divisor. A linear divisor, a line that is of the form x minus a number, where k is just any number. Actually, it doesn't even have to be real. It could be imaginary. So k is any number. And the way synthetic division works is you put the coefficients of the dividend here, the y-intercept over here, so just the coefficients. You don't need any variables. And when you go through the process, your quotient is going to manifest right here. And whatever number occurs here is your remainder. And the k value, this is what I call the window, but the number that goes in here is the 0 of your divisor. So what would make x minus k equals 0? K would. So that goes right here. And the process is, I'm going to have a lot of arrows here, but the process is pretty simple. It's just multiplying and dividing. The first thing you do is drop your leading coefficient, and then you take k times the number down here and put it in this middle section. So k times the number down here, and you put that answer right here. And then you add the coefficient. You add the 2 coefficients, which gives you another number. And then you take k times that number and put the answer up here. And then you add these 2 numbers, and then you take k times that, and you put the answer here. You add again. You keep on doing this for as long as you have numbers in your dividend, until finally you've added your y-intercept and you got your remainder. It's actually much simpler than what I just described. So here's an example. This is 2x cubed minus 3x squared minus 5x minus 12 being divided by x minus 3. Long division. So you go through the whole process, and look, the remainder is 0. That's great news. That means x minus 3 is a factor of this, because the remainder is 0. And so is 2x squared plus 3x plus 4. That is a factor of the 2x cubed polynomial. But to do it by synthetic division, the coefficients of the dividend, 2, negative 3, negative 5, go here, 2, negative 3, negative 5. The y-intercept goes here, which is negative 12. What value would make this divisor equal 0? 3 would. So 3 goes in here. And then you start your process by dropping this number, 2, and then you multiply and add, multiply and add. 3 times 2 is 6, so that goes there. And then you add. Negative 3 plus 6 is 3. And then you multiply. 3 times 3 is 9. And then you add. Negative 5 plus 9 is 4. Then you multiply. 3 times 4 is 12. and then you add negative 12 plus 12 is 0, and you are done. Now, this is the quotient, but just writing down 234 is going to be very, very wrong. It is a polynomial that is 1 degree less than your dividend. Your dividend was a cubic polynomial, so 1 degree less is going to make it a quadratic. So it begins as 2x squared. I've got a positive 3, so plus 3 times x, and then a positive 4 plus 4. So this is your quotient, the same quotient as I got long division. Let's practice a couple more times, and then we will be done. So I'm going to divide this polynomial by x plus 4, and I'm going to do synthetic division. My divisor is a line. So what number will make x plus 4 0? Negative 4 goes into my window. The coefficients go here, 1 for x to the 4th, 3 for this, negative 3 for this, 3 for 3x, and then the y-intercept. And then how do I start this off? Drop that first coefficient down, and then multiply and add. Multiply and add, multiply and add. Negative 4 times 1 is negative 4. And then you add. That gets to negative 1. Negative 4 times negative 1 is positive 4. Then you add positive 1. Negative 4 times 1 is negative 4. And then you add. You get negative 1. Negative 4 times negative 1 is positive 4. And then you add. And again, you get 0 as a remainder. That means that x plus 4, what you divided by, it was divided evenly. So x plus 4 is a factor, which from the last lesson, if x plus 4 is a factor, we know that negative 4 is a 0. It is a 0 of this polynomial. Last one. What do you notice here? I hope you can see that we would need a placeholder. You've got x to the 4th, x to the 3rd, and then x to the 1st. You skipped over x to the 2nd, so we need a placeholder. So here are my coefficients for my dividend. 0x squared, negative 3, and then, whoops, this should be negative 1 for my, my y-intercept. And then what goes here but the 0 of the divisor. So 2 would make that divisor 0. Drop down this number, and then multiply and add. So 2 times 2 is 4. Add, you get 7. 2 times 7 is 14. Add them up, you get 14. 2 times 14 is 28. Add them up, you get 25. 2 times 25 is 50. And if you add them up, you get 49. So our final answer is it's 1 degree less than the dividend. The dividend was x to the 4th. So this is 2x to the 3rd plus 7x squared plus 14x to the 1st plus 25 plus 49 over the divisor. So 49 over x minus 2. And that is synthetic division.